Swayam Prabha. Digital India. Educated India.
Hello, I welcome you all in the course on refrigeration and air conditioning. Today we will discuss the aircraft refrigeration cycles. In this lecture we will be covering the requirement of cooling in airplane, why use air cycle, type of airplane refrigeration system. Airplane is a special type of aircraft. Even a helicopter is an aircraft, even a hot air balloon is an aircraft, but airplane is a special type of aircraft which has weighing a specific body, it can be maneuvered and it can be controlled and powered. So, basically in this lecture we will be focusing on airplane refrigeration systems, and first of all we will discuss the requirement of cooling in airplane. Now, airplane moves at 1000 meter at around 10 kilometers above the earth's surface, where temperature is minus 50 degrees centigrade and pressure is approximately 0.15 bar. Neither we can survive under pressure of 0.015 bar, nor we can survive under temperature of minus 50 degrees centigrade, because for our comfort the required temperature is 25 degrees centigrade and pressure has to be in ideal condition 1 atmospheric pressure or 1 bar pressure or close to 1 bar pressure. In any case 0.15 bar pressure, no human being can survive. So, the pressure has to be increased in airplane and temperature has to be increased. Higher we go from the earth's surface, we find that the temperature goes down, right, because the closest layer of air over the earth's surface is troposphere. Troposphere stretches up to 12 kilometers above the earth's surface. So, most of the aircrafts they move in troposphere and temperature is, most of the cases it is close to minus 50 degrees centigrade, irrespective of the fact the temperature on the earth's surface. If we draw a chart for the variation of temperature with altitude, suppose the altitude is here is 12 kilometers or 10 kilometers and temperature is 20, this is 40 and this is minus 50. So, at 10 kilometers altitude the temperature remains same. This temperature does not vary with the temperature on the earth. Now, in an aeroplane, for the air conditioning of airplane, now we call it airplane, in some of the part of the world it is called aeroplane. An airplane. Both are same. Aeroplane and airplane both are same. This terminology airplane is mostly used in US and Canada, and rest of the world, in most of the part of the world it is called aeroplane. So, whether it is airplane or aeroplane, the question is whether cooling is required in aeroplane, because the temperature is minus 50 degrees centigrade where in the area where it is moving. So, the cooling is really required for aeroplane. Cooling is definitely required for aeroplane. There are certain reasons, the reason being the ramming of air. When the plane is moving with the velocity of 1000 kilometers per hour, let us say our plane is moving, for the sake of convenience, 900 kilometers per hour. If we convert this velocity into meter per second, it is going to be 250 meters per second. The air is coming on the plane because plane is moving into the air, or vice versa, the air is coming, we can assume that air is coming over the plane with the velocity 2 meter per second, and this kinetic energy is imparted to the plane surface. In that case, using law for open system, H is equal to how much, 250 square by 2, V square by 2, and this is delta H, and this is equal to delta T is going to be 250 square by 2 multiplied by Cp. This is Cp delta T, so multiplied by Cp, it is 1005, because Cp for air is 1005 joules per kg Kelvin. So, this is going to be equal to 31.1 degree centigrade. This is the temperature rise. This is the order of temperature rise when high velocity air strikes the plane and kinetic energy of air is converted into the enthalpy of air. In addition to that, there are solar radiations. Beyond the earth atmosphere, it is an estimate the solar radiations are 1353 watts per meter square. Even on the earth, for example, even in at this place, the solar radiations are approximately of the order of 700 watts per meter square, and the area where the plane is cruising, we can always assume that the radiations falling on the plane surface is approximately 1000 watt per meter square or 1 kilowatt per meter square. This much heat is coming to the plane. Pressure of air inside the cabin is also an issue because outside pressure is 0.15 bar. So, air has to be pressurized before it is supplied to the cabin. A lot of heat is dissipated by the control devices also. There is a lot of electronics in the plane, and these electronic devices, they also dissipate the heat. And if we take a rough estimate, let us say if a plane of a passenger capacity of 150, approximately 6 to 7 tons of cooling will be required for cooling the electronic devices itself. Heat release from the occupants. Occupants of the plane, when they are sitting and are not involved in any activity, they dissipate 90 watt of heat as sensible heat and 30 watt of heat as latent heat. Total is 120 watt, or roughly we assume 100 watt per passenger. So, if there are 200 passengers in the plane, so 200 multiplied by 0.1 kilowatt, it is 20 kilowatt, and 10 to 20 kilowatt if you divide by 3.5, 20 kilowatt divided by 3.5, it will be approximately how much? 20, 5.7 tons of refrigeration will be required. So, there are many sources for heat transfer to the plane, and because the plane engine is also at a very high temperature. So, through conduction or radiation, the heat is also transmitted from the engine of the plane. So, finally cooling in a plane is required. Now, the second question is, why use air cycle? We can have many other cycles also, but why we want to use air as a refrigerant for cooling in aeroplane? First of all, air is cheap. That is always a consideration when you purchase anything, that the cost has to be low. Environmentally benign, safe and non-toxic. That is the property of the air which has to be highlighted, because any gas we use in aeroplane has to be non-toxic, inflammable, safe and environment friendly. air cycle equipment are extremely reliable because the pressure ratio in air cycle is less in comparison to the pressure ratio in vapor compression cycle. So, the maintenance cost is less and systems are reliable. So, reliability is also another issue in airplanes. The system, whatever system we use in airplane has to be reliable. The performance of air cycle unit does not deteriorate as much as that of vapor compression unit when operating away from its design point. So, off design performance of air cycle is very good because any instrument, even if you purchase automobile for yourself, you never drive your car or a scooter on design conditions. Like for example, if you have a motorcycle optimal design condition is ideal road conditions, speed 45 kilometers per hour, but you never drive motorcycle always at 45 kilometers per hour. When you are in congested area, you are driving in first gear maybe 3 kilometers per hour, right. So, off design performance of such machines carry a lot of importance. So, for air refrigeration cycle, its off design performance is also good. When operating in a refrigeration cycle, this air refrigeration cycle also produces heat because heat is rejected, and this rejected heat can be used for other processes in the plane which require low level of energy. Advantages of air cycle for airplane refrigeration: no cost refrigeration involved, the air is quite cheap. Main compressor of gas turbine is used. So, in a plane, because the plane is powered with the help of a gas turbine, and for the gas turbines a compressor is used. So, the same compressor can also be used for compressing the air for the purpose of compression. So, a separate compressor is not required if you use air compression cycle. If you use any other cycle, vapor compression cycle, a dedicated compressor shall be required for refrigeration cycle. But if you are using air standard cycle, or sorry, this air refrigeration cycle, in that cycle the same compressor which is used for the gas turbine of engine can be used for air refrigeration purpose also. Chilled air is directly used for cooling. So, chilled air you can directly inject into the cabin. This is not possible in the other vapor compression cycle where some chemicals are used as a refrigerant, because in this cycle the benefit is that the air is used as a refrigerant. So, chilled air can directly be injected to the cabin. Minor leakage is not a problem, because if there is a leakage up in the atmosphere 10 kilometers away from the earth's surface, if there is a minor leakage, that can be resolved. This issue can be resolved by tapping air from the outside, but if you are not using air, instead of air if you are using some other chemical as a refrigerant, this may not be possible. Low pressure in the system, this low pressure leads to low maintenance. I have discussed earlier. Weight per ton of refrigeration is low in air refrigeration cycle. It is very light in weight. So, that is for any aircraft application, this is one of the major criteria. The system has to be very light in weight. So, weight per ton of refrigeration in air cycle is low, and because the RPM of the compressor is very high, it can go up to 60,000 RPM. Air is non-toxic and non-flammable, we have already discussed that, and refrigeration system is light in weight, just now we have discussed. Now, there are certain disadvantages, because there are certain advantages of air cycle, air refrigeration cycle, there are certain disadvantages also. Low coefficient of performance, there is a major disadvantage of air refrigeration cycle which always goes against it, and that is why we do not use air refrigeration cycles in our buildings. In our buildings we do not use air refrigeration cycles. The reason being, the COP of the air refrigeration cycle is approximately 0.4. COP of it is close to 0.4, approximately 0.4. COP of vapor compression cycle is approximately, nowadays it goes up to 3.5. So, it is 8 to 9 times of this. So, if you use air cycles, this can be also be mooted, that why don't we, if it is so beneficial air standard cycle, why can't we use the air refrigeration cycles for our buildings? We cannot use, it is not advisable to use air refrigeration cycles for the building, is because the COP, coefficient of performance of air refrigeration cycle is very low in comparison to the coefficient of performance of vapor compression cycles. Second thing is sensible heating of refrigerant takes place. If you look at the air refrigeration cycle, the cooling effect we get from here, because process 4 to 1, the air extracts heat from the surroundings and that produces the cooling effect. Now, in order to produce this cooling effect, the sensible heating of air takes place, Cp delta T. Now, in vapor compression cycles, vapor compression refrigeration cycles, the this heat transfer during refrigeration and heat rejection takes place during boiling and condensation. We will discuss vapor compression cycles later on in details, but here I must tell you, in vapor compression cycle, this process of heat extraction from the surroundings, during this process the boiling of vapor takes place in vapor compression cycles. Similarly, during heat release during condensation, it is not sensible cooling in vapor compression cycle, it is condensation of the vapor. It has certain advantages because here we are making use of latent heat of the fluids. So, a small quantity of the fluid has to be circulated in the system in order to produce the same kind of refrigerating effect. Now, because here the sensible heating is taking place, mass flow of air has to be very high in comparison to the mass flow of refrigerant in compression of in case of vapor compression system. And obviously there is another problem of freezing of moisture in the air. If some moisture in the air is present, it will get freezed and it will cause problems in operation of the system. Types of airplane refrigeration system. So, there are 4 types of airplane refrigeration systems: simple, bootstrap, regenerative and reduced ambient. Simple is not that simple, I mean like this simple air refrigeration cycle. It is a modification of this cycle. Right now, we will discuss that. Now, another type of system is a bootstrap system. Bootstrap system, the output of this expander is used for further compression of the air so that we can get the maximum refrigerating effect. So, these two are there. Then these two type of system, simple and bootstrap, can also have arrangement for evaporative cooling. So, evaporative cooling will further enhance the performance of the system. The third one is a regenerative system and fourth one is a reduced ambient system. So, we will discuss these systems one by one. Let us take simple air refrigeration system. The simple air refrigeration system, as you can see in the figure, it is at point 0, we assume that air is coming with a certain velocity. I will draw this process on temperature entropy diagram. Stagnation of air takes place. Due to this stagnation, the pressure of the air rises and we get state 1. This action is known as ramming action. So, the kinetic energy of air is converted into the pressure energy, and in this process the pressure of air also rises. This state 1 is also shown in the figure. Now, we are using here the same compressor as it is used for the gas turbine of the aircraft. Now, out of this compressor at state 1, the stagnated air is attained. This stagnated air is compressed in the compressor and we get state 2 as shown in the figure. Now, this at state 2, the air is at very high temperature and high pressure as well. Now, this air is cooled with the air available at state 1 and cooling of air takes place, and that is process 2 to 3. Now, at 3 there is an expander. Now, at 3 there is an expander and this expander is used for expansion of air. The expansion of air takes place and it is not expanded up to 0, it is expanded up to here above, because this pressure is 0.15 approximately bar. So, air is expanded up to 1 bar or 0.9 bar and then it is supplied to the cabin. The power developed in the expander is used to run the fan. This air is also used for cooling purpose. Now, second cycle is bootstrap air refrigeration cycle. Bootstrap means you must have seen a strap on the boot. So, bootstrap means over and above. So, here in bootstrap cycle, initial processes remain same. I mean, if we take process 0 to 1, ramming action takes place. Now, 1 to 2, compression takes place in a compressor, and after the compression, the cooling is done. After the compression, the cooling is done up to state 3 in a heat exchanger, and this cooling is again done with the air available at state 1. After state 3, another compressor is provided. This compressor is powered by the turbine, which is also an expander. So, this state 3 air is further compressed. Air is further compressed with another compressor and we get the state 4. After state 4, again the cooling takes place and we get the state 5. The cooling is again done with the air available at the entry of the compressor. So, we get the state 5, and after state 5 expansion takes place in an expander and air is supplied to the cabin. Now, here in this case, how it is beneficial? Because here in this case expansion is taking place at higher pressure. This is to P4. So, P4 is greater than P2, or the pressure ratio, instead of this, if we had expanded the air from here, we could have got higher temperature. Since we have compressed it and cooled it and we have attained the state 5, you can see we are getting a lower temperature. So, the benefit of the bootstrap type of refrigeration system is that the output of the turbine, because this bootstrap type of system is used for aircraft with relatively higher speed. Bootstrap air refrigeration cycle is used for the aircraft where speed is relatively high than in the case of simple air refrigeration cycle. So, in a bootstrap cycle, air fan for the purpose of cooling is not required. So, the fan can be eliminated, and this fan, instead of this power of expander going to the fan, it goes to the compressor. So, compressor is driven by the expander or the turbine, and this compressor gives the additional pressure rise in the air, which results in lower temperature after expansion at state 6. Now, I complete my lecture here. In the subsequent lectures, I will take remaining two types of refrigeration system, that is regenerative type and reduced ambient type.